My dear friends, now we are solving October-November 24 paper 4 variant 2, and in this portion of the recording we will be solving thermal physics and physics of waves questions from this year exam. Dear student, that is done. Check it out. If there is anything left, let me know. I will be doing that inshallah tomorrow 12:35. Don't worry, just check it out after the lesson today. Figure 4.1 shows the pressure cooker on an electric heating element. The cooker has tight fitting lid at the top. That is always the tight fitting lid so that the steam cannot escape. So the pressure cooker is half full of water. As the water is heated, some water evaporates before the water boils. Some water evaporates before the water boils. Describe two differences between evaporation and boiling of water in the cooker. Simple, you know, this is a formula question. Mohammed, very good, you have answered it. So we have to talk about both of them. Okay, so first of all we will say evaporation takes place at the surface. Evaporation takes place at the surface of the air water, while boiling throughout. While boiling throughout the water. Second point is evaporation takes place at any temperature below boiling any temperature below boiling while boiling at fixed temperature. This way, two differences. Already you have discussed and you have told me. As the water is heated, the pressure of the gas inside the cooker increases. Explain this increase in the pressure in terms of the particles. As the water is heated, the pressure of the gas. You know, when the water will be heated, here 1/4 mark is one extra mark and one new way of thinking which I never discussed with you before. So when the water is heated, it means it will either boil or it will either evaporate. So when the water will evaporate, so it means more number of gas molecules will be there, and we want to get the pressure of the gas. So more number of gas molecules will be there, so they will move faster or they will gain kinetic energy. They will collide more frequently with the walls of the container and they will exert greater force, and pressure is directly proportional to the force. So like this you can score these 4 marks. So now I am starting to write the answer one by one. First of all, I will definitely be writing this point that as the gas is heated, number of gas particles, no more molecules here, number of gas particles are increased and gas particles move faster. Gas particles hit या collide the walls of cooker more frequently, more oftenly, more frequently, and exert greater force. And then you can write even this way formula that pressure is equal to force per unit area. This implies that pressure is directly proportional to force. So like this, it is more than for 5 marks, almost 4 marks plus explanation we have given. So please read the question. And first point I would like to say it again because first time I have written it like this. As the water is heated, the pressure of the gas inside the cooker increases. Explain this increase in pressure of the in terms of particles. Now, my dear friends, it is not necessary that you have to definitely write the first point. We never have written it before. So even you can start saying, as the gas is heated, gas particles move faster. So they collide with the walls of the cooker more frequently. So they exert greater force, and pressure is equal to force over area, and pressure is so greater force. It means greater pressure, or you can write pressure is directly proportional to force. But I was just willing to write this point also for you people that gas is heated, so it means something here, not gas is heated. Why gas is heated? It is water is heated. Thanks, I was repeating, so I found this mistake. As the water is heated, number of gas particles are increased because water is converted into steam, and gas particles move faster. Gas particles hit the walls of the cooker more frequently, exert greater force. So pressure is equal to force over area, and pressure is directly proportional to force. If there is any question or ambiguity, please feel free and you can ask me now. Okay, my dear friends, next is then on a sunny day, the temperature of black tarmac road and the air above the road increase. Explain why the surface temperature of the tarmac increase. It's very simple. It is, tarmac is black color. It is a very good absorber of infrared radiations. So, tarmac is a good absorber of IR, infrared radiations. So, tarmac absorbs infrared radiations from the sun, and we know one thing also, that is enough for 2 marks, and also we know one thing that infrared radiations are basically the heat on the move. Infrared radiations are what? They are the heat on the move. State the method of thermal energy from tarmac to the air immediately above the road. This tarmac is a solid. So if it is a solid, immediately to the air, so that solid, it means that is conduction. And then state the main method of thermal energy transfer from air immediately above the road to the rest of the air. Air is a fluid, and in fluids, heat is transferred by convection. Okay, so next is then explain why the surface temperature of tarmac is higher than the surrounding air temperature. So we can say black tarmac is a good absorber of infrared radiation than air. So question is, why this temperature of the tarmac? This is one reason, and another reason is the quantity, the amount of tarmac. So tarmac has a thin layer, while the volume of air is large. That is bigger in amount. The volume of air is large. So these are the two reasons that tarmac is getting higher. Temperature of the tarmac is getting higher as compared to the surrounding air. One thing, black tarmac is a good absorber of radiation. That's where its temperature goes up. And second thing, the magnitude or the size or the quantity of tarmac is much smaller as compared to the quantity of the air. So that's why temperature of tarmac is higher than the temperature of surrounding air. Okay, my dear friends, now please, if there is any question here, you can ask me again, but I don't think so there is something special. This was just about the three modes of transfer of methods of transfer of thermal energy, and about the good absorbers and good radiators. That's what was the topic. Okay, my dear friends, stay blessed.